Okay, so on note 6.4, we're going to be analyzing graphs of quadratic functions. So remember the three forms that we've already gone over for which a quadratic function can be in: standard form, vertex form, and root form. Okay, so we'll be using that in order to find our vertex and find our points on our parabola, and then we'll be filling in all this information here. So notice on number 1 that it's in standard form. So when you have standard form to find the vertex, you're using the formula x equals negative b over 2a. So your a equals 1, b equals 4, and remember c is your y-intercept, it equals 3. So plugging in, we're going to get negative 4 over 2 times 1. So our x value of a vertex will equal negative 2. To find the y, we can plug that in. So that's going to give us 4 minus 8 plus 3. So that would be negative 4 plus 3, so we should get negative 1 for the y value of the vertex. Okay, so our vertex is negative 2, negative 1. I'm going to fill that in on the table, and then I'm going to choose 3 x values that are either larger than negative 2 or smaller than. It doesn't really matter. So negative 1, 0, and 1. Okay, so when we plug in a negative 1, we'll just plug it back into the original. So when we plug that in, negative 1 squared plus 4 times a negative 1 plus 3. That's going to be 1 minus 4, which would give us negative 3 plus 3, which equals 0. When we plug in a 0, remember when x is 0, that's your y-intercept. We already found that. It's c, so 0, 3. And then when you plug in a 1, that's going to be 1 squared, which is 1 plus 4, so 5 plus 3 is 8. So you can just type that in. Okay, so we're going to go ahead and plot those points. Negative 2, negative 1. And then negative 1, 0. 0, 3. And 1, 8. So there's our half of our parabola. We're going to draw the axis of symmetry line, which goes straight through your vertex, and then we're going to reflect those points over that line in order to find the other half of your parabola. And then we're connecting the points. So there's our parabola. Okay, so we're going to find the axis of symmetry. The axis of symmetry is a vertical line that goes straight through your vertex, but it also goes through the x-axis. So your equation on your axis of symmetry, you have to write x equals, and then wherever that it crosses the x, which is at negative 2. It will always be the x value of your vertex because we know that it goes straight through your vertex. Don't forget the x equals though. If you just put negative 2, it's wrong. It has to be x equals negative 2, so we know that it's a vertical line. Okay, so then you're going to find your max or min value, which is your y value of your vertex. So notice that our vertex is at the bottom of our parabola, so that will be a minimum value, which means the smallest value, and that y value was a negative 1. So that's the smallest y value that's being used there. Domain, we're going to look at our domain, which are your x. That wasn't a very good curly bracket. So a curly bracket, if you look at the x, notice that we have arrows going both directions, so our domain of our parabola will be all real numbers. The range, which are your y values. Notice that if you look at your y-axis, that the smallest value was -1 and it's everything above that. So y would have to be greater than or equal to -1. The roots, remember, are your x-intercepts. So where it crosses the x-axis. So it crosses at -3 and -1. So you should have 2 roots there unless it's a double root. Okay, so now let's take a look at number 2. So you need to check and see what form you have. So notice that we have vertex form here. Remember, when it's in vertex form, to find the vertex, vertex is HK. Notice that H will be 2, because remember it's the opposite because the form is x minus. And then your K, notice that we're not adding a constant after our terms that are squared, so that's going to be a 0. So there's our vertex. And then I'm going to choose 3 x values that are either larger or smaller than the x value of the vertex, so 3, 4, and 5. Plug in those in. Do inside of parentheses first, so that would be 1 squared, because we get rid of the exponent. So that all together, that's 1 times 3, we get 3. Plugging in a 4. You're going to get 2, and then square it, you get 4. So 3 times 4, we get 12. Okay, so if we were to plug a 5 in, we know that it's going to go off the graph because 4 went off the graph, okay? All right, so let's plot our points. So 2, 0, and then 3, 3. And those are the only 2 that we have there because the other one goes off the graph. So let's go ahead and draw our axis of symmetry line. And then connect. Okay, so your axis of symmetry, remember it's always x equals, it's a vertical line that crosses through the x on this example at 2. Remember that value is always the x value of the vertex. Notice your vertex, to determine if it's a max or a min, it's at the bottom, so it would be a min, and that smallest y value that's being used is 0. Your domain, you have arrows going both directions, so your domain is all real numbers. Now we'll tell you, any parabola that you have that opens up or opens down, your domain will be all real numbers every single time. Okay, so the range is not all real numbers because look at your y-axis. The smallest y value that's being used is 0 and everything above it, so y would have to be greater than or equal to 0. The roots, notice that we only have 1 root, and that's also our vertex, so that's called a double root. And that root was 2. You could write 2, 2, but you don't have to write it twice. Okay, so let's take a look at number 3. Okay, so notice this one that we have, it's in root form. So we're going to find the roots. So notice on the form it's x minus, so that would be a positive 2 for the first one. So R1 equals 2. And then for R2, that would be a negative 2 because it's the opposite. Okay, remember to find the vertex when you're in root form, you first have to plot your 2 roots. So 2, the roots are your x-intercepts, and negative 2. To find the vertex when you know the two roots, you know the vertex is in the middle of those two roots. Notice the x value in between those would be 0. So we know the x value of the vertex is 0. To find the y, we can just plug it in. Doing what's inside parentheses, we get -2 and then 2 there. So multiplying these two, we're going to get 4 times 2, which would give us 8. So 0, 8 would be our vertex. And then we already found our two roots. So those were also two other points that we have. So I'm going to choose 1, 2, and 3. If we plug in a 1, you're going to get -2 times a -1 times 3. So that's 2 times 3, which would give you 6. 2, if we plug a 2 in, we already have that point. When x is 2, your y is 0. That's one of your roots. And then we'll plug in a 3. Doing what's inside parentheses, we get a 1 on the first one and then a 5. So that's going to be -10. So let's go ahead and plot those. The vertex is 0, 8, 1, 6, 2, 0 we already have, and 3, -10. I'm going to draw the axis of symmetry line. And then we can connect our points. Okay, so now also remember that we talked about the a, which is the coefficient in the very front. If it's a negative, remember your parabola should open down. If it's a positive, remember it should open up. Okay, axis of symmetry, it's the vertical line, so it should be x equals wherever it crosses the x. It's also that x value of your vertex because the axis of symmetry goes straight through it. So x equals 0. Notice this time that our vertex is at the top, so that would be the maximum value. That maximum y value that we have there is a positive 8. Remember we said on the front, all real numbers for domain because we're always going to have arrows at both ends of our parabola. But the range will not be all real numbers. If you look at the y-axis, that highest y value that's being used is 8, and then it's everything below. So y would be less than or equal to 8. We already found the roots because it was in root form.